Let's remember that momentum is a vector, and I've been writing it very often without the vector symbol because I don't want that to make things more confusing, but it is a vector because velocity is a vector. And so when we're looking at momentum in two dimensions, we're looking at, when our velocity has an x component and a y component, then our momentum would also have an x component and a y component. And remember, we do all of our math for x components separately from the math we do for our y components. So one way to say momentum is conserved would be to say P initial equals P final as vectors, or we could say the x component of P initial has to equal the x component of P final, and the y component of P initial has to equal the y component of P final. So again, we would do the exact same math that we've been doing, but you do all the x components in one equation and all the y components in another equation. So let's look at an example that involves conservation of momentum in two dimensions. So press pause, take some time to work through this, and then press play to go through it with me. Okay, so we have something with an initial velocity that's in the north direction, and then something else with an initial velocity in the east direction. So already we can tell that there is this these two dimensions involved here. There's the y dimension and the x dimension. We know the cars stick together. That's telling me that this is a perfectly inelastic collision. And all we know about what happens afterwards is the angle. We don't know what the v final is, the x component of v final or the y component of v final. We just know this angle. So let's look at how we're going to set this up. I'm going to still have two events, an event right before the collision and an event right after the collision. Now I'm going to look at my total momentum initially in the y direction, okay, because in the y direction I only have momentum from the Cadillac, right? That's going north. The VW, the Volkswagen, is going east. So my total momentum of the whole system would be the momentum of the Cadillac in the y direction plus the momentum of the Volkswagen in the y direction, but the momentum of the Volkswagen in the y direction is 0. So my initial momentum in the y direction is just the Cadillac's momentum. And so VCI here is going to be that 3 meters per second, and it's north. Then my total momentum in the x direction initially would be the momentum of the Volkswagen in the x direction plus the momentum of the Cadillac in the x direction, which is 0 because it's moving perfectly north. So the only momentum I have in that x direction is the Volkswagen's. Afterwards, I'm going to have momentum in the x and y directions. The momentum in the, I don't know why I did the y first, but the momentum in the y direction is going to be the mass of the Cadillac plus the mass of the Volkswagen. They're acting as one single mass times the y component of the final velocity. And my total momentum in the x direction is going to be their total mass plus times the x component of their final velocity. I do not know this value, and I do not know this value, so I have two unknown variables. But what I can do is I can say that the x component of my final velocity is equal to the magnitude of my final velocity times cosine theta, and the y component is equal to my magnitude times sine of theta. So I can plug those into here and look at using conservation of momentum first. I'll look at the y direction. Okay, so I'm going to have, this is my initial momentum in the y direction, and this is my final momentum in the y direction. And when I plug in all the values, there's the mass of the Cadillac, that initial velocity of the Cadillac in that x direction. There's the total mass of the Cadillac plus the mass of the VW, and that final velocity is unknown. And then I can, and I plugged in the angle here. That tells me my final velocity, 3.49 meters per second. And now that I know that, I can look in the x direction, because in the x direction, I did not know how fast the VW was going. I did not know this value. So now I can plug in, using this expression here, I can plug in for V final because I just solved for it. And I plugged in all the other numbers, and I can find that my final velocity, or my initial velocity of the VW is 8.6 meters per second.